Hey, it's Dorita here, and so right now I would like to show you a new way that we have our students do multiplication, either 2-digit times 2-digit or 2-digit times 3-digit, without using the regular old school algorithm that we grew up learning. The algorithm tends to have a little bit of problems with their number sense. If they forget if they forget to add the 0 after they've multiplied their ones, then oftentimes they'll make that mistake, add up the numbers, and they don't have a clue that their answer is wrong. So what we like to do, and this is really kind of a 2-for-1 good strategy to use, we call this the area method for multiplication. So not only does it take away that different leaving off the zeros and having the wrong answer, it also gives them an idea of what area actually is when we get to where we're multiplying the length times the width to find area. So it's kind of a 2-for-1 good strategy. Anyway, to do a 2-digit by 2-digit multiplication, what we're going to do is we're going to set it up like this. Let's say we want to multiply 43 times 15. What we're going to do is we're going to set up this rectangular section over here. We're going to decompose 40 into 40 plus 3 and decompose 15 into 10 plus 5. And then that way we've got 4 sections that need to be filled so that we can know what the total product, which is the answer, is going to be. Now over here, I always like to have my students give a little bit of an estimate of what they think the answer is going to be. In this case, if they say that 43 times 10 is 430, and then 43 times 20 is 860, 43 times 15 should be right between those two in the middle. So I would say it's going to be somewhere around 640. Okay, so that gives us a good starting point. So let's look at what happens whenever we actually do the multiplication. Okay, so let's look at this. We've got 43 times 15. I'm going to multiply 10 times 40 to get 400, 10 times 3 to get 30. Then I'm going to come down here. 5 times 40 is 200, and 5 times 3 is 15. Well, I add across to get 430. I add across to get 215. My answer is 645, and that really goes with the estimation that I did previously. And so if you notice that as you're doing this, you're not going to have the common mistake of, after you multiply 43 times 5, forgetting to put that 0 in the next partial product. So let's look and see what it looks like if we're doing a 3-digit by 2-digit. So if you look at this, it's still the same thing. We're going to multiply 216 times 34. Now notice, instead of having a 2 by 2 array on this one, we're going to have a 3 by 2. 216 gets decomposed into 200 plus 10 plus 6. I'm just using the place value values. And then 30 plus 4. So here's my estimation. 200 times 30 is 6,000. 200 times 40 is 8,000. Now my answer is going to be between those two. And we'll see, I did round 216 down, and so that's going to affect that. But my answer should be between 6,000 and 8,000. Okay, so doing the math, we've got 30 times 200 is 6,000. 30 times 10 is 300. 30 times 2 is 180. When I add those across, I get 6,480. And then 4 times 200 is 800. 4 times 10 is 40. 4 times 6 is 24. When I add those across, I have 864. When I add them all up together, I get 7,344, which actually is very reasonable when I look at the estimate that I had. So that is one way that we have the students do the multiplication now, and it seems to help with their number sense and with their accuracy in doing it, and it really doesn't take any longer. So I hope you liked this little lesson on multiplication strategies, and please like and share below. Subscribe to the YouTube channel to get further updates, and also check out my blog at www.DoritaMcCullers.org, and I'll see you on the next video. Thank you very much.